Hello everybody, we're going to continue our lesson on integrating functions of the form f of ax plus b. That's section 18f. And our last example that we finished off with in the previous video, we were just finding the indefinite integral and we had this last situation here. So I just wanted to show you a couple of tricks. First, for this one, if I have 6x plus 3 to the exponent 4 in the denominator, I'm going to rewrite with a negative exponent. Then I can apply my power rule. So I can think of keeping this base, adding 1 to the exponent, and dividing by the exponent plus 1. And then I can think about also dividing out this 6, because if I took the derivative of this expression, I'd have to take the derivative of the inside as well, and that would leave me with a coefficient of 6 that I don't want. So I'm going to divide it out. And I've got to include that plus c. And then I tidy it up just a little bit by multiplying together those denominators. Okay, and remember that x, we have to state our restrictions. X cannot be negative 1/2, otherwise the denominator would be 0, and that would be a bad thing. Oops. Okay, next we're going to look at some examples with some trig functions. And if we want to integrate something like sine of 3x, even though this isn't 3x plus a constant, that constant part, the plus b, is not going to be a part of our final answer anyway, so it doesn't matter. This is just 3x and not 3x plus 1, just for your reference. So if I take the integral of sine of 3x, remember that the integral of sine of x is negative cos of x, so this will be negative cos of 3x, but I also need to multiply by 1 over 3 to divide out this factor if I was taking the derivative. I need to add that plus c as well to account for a constant that could be there that we aren't aware of, or we don't have any information about. Okay, if I want to look at part b here, 2 cos of negative 4x plus 1, if I took the integral of that, I'm going to start by breaking down this integral a bit. I'm going to break this into 2 cos of negative 4x, and I could break it into the integral of 1. I didn't do that in this solution. And I can pull that 2 outside of my integral sign and just take the integral of cos of negative 4x. The integral of this would be sine of negative 4x and multiplied by negative 1 over 4. And the integral of 1 would be just x, and we include our plus c. Last, I tidy up by multiplying those two factors together and simplifying a bit. Okay. For my last example, if I have 3 cos x over 2 dx, the integral, I'm going to start by pulling out the 3, so I just have cos of something. The integral of cosine is sine of that something, in this case x over 2, but I need to divide out that coefficient of x. Remember, there's like an invisible 1/2. Oh, well, there's like an invisible 1 in front of the x, so this is like 1/2 x. So I've got to take 1 and divide by that coefficient of x, which is 1/2. 1 divided by 1/2 gives me 2. So 3 times 2 is 6. Sine of x over 2 plus c. Okay, now we're going to get into a couple more examples where we're going to look at the difference between an indefinite integral, where we have this plus c. Now, I called this a definite integral, but it's not always called that. A definite integral has to do more with boundaries than with finding this final value, but this part is still called an indefinite integral. So if I wanted to if I know the derivative is 2e to the negative 2x, and that f at 0 equals 3, I need to find the original function. So I need to integrate 2e to the negative 2x. Remember that if I took the integral of this, that would be e to the negative 2x, and I'd have to multiply by 1 over negative 2, since the coefficient of x is negative 2. And I have that 2 that I had brought in front of the integral sign before. When I multiply those together, I get negative e to the negative 2x plus the c. So that must be my original function. But I can actually figure out what c is because I'm told that f at 0 equals 3. So if I plug in 0 for x and 3 for f at 0, I can find out that c is 4. And therefore, my original function must have been negative e to the negative 2x plus 4. Okay, now I'm going to go through the rest of this example in the next video.